Hello students, welcome to the video lectures of software engineering. So today we are talking about the art of debugging concept. So the debugging occurs as a consequence of successful testing. So previously in our video lectures, we have seen the process of testing, the various testing strategies and various testing techniques, what we have. And now we talk about this art of debugging. So debugging occurs as a sequence of successful testing. That is, when a test case uncovers an error, debugging is a process that results in removal of the error. So if you observe the diagram, you can see. So the identifies causes, corrections, regression tests, test cases are fed to the computer after debugging is done. Okay. Now, the art of or the debugging is a crucial step in our software development process. Okay. So as mentioned, the debugging will occur when there is a successful testing that has occurred. Okay. So once a issue is found, so the debugging is in the act of, tracing and locating and correcting the underlying problem. So the key idea is the testing will show there's a problem and the debugging will help to fix it. Okay. That is what this depicts us. So next, the debugging process. The debugging process begins with the execution of a test case, right? So the debugging process starts when the actual output of a test case does not match the expected result. Okay, so the symptom is visible, but the cause is hidden in the code, right? Now, the results are assessed and a lack of correspondence between expected and actual performance is encountered. So in many cases, the non-corresponding data are a symptom of underlying cause as yet hidden. So the debugging process attempts to match symptom with cause, thereby leading to error correction. So the debugging process will always have one of the two outcomes. First is the cause will be found and corrected. Second is the cause will not be found. So the debugging approaches we have are, in general, three categories for debugging approach may be proposed. First one is brute force, next is backtracking, and next is cause elimination. Okay. So the goal is to match the symptom to the cause. So the two possible outcomes are either we'll find and fix the cause or if we fail and to locate the issue. Clear? So debugging is kind of, both analytical and experimental. That's what is depicted here. Now next, the approach is what we have for, debugging. Okay, so there are commonly three approaches, as said just now. That's brute force, backtracking, and cause elimination. So we see one by one. The brute force category of debugging is probably the most common and least efficient method for isolating the cause of software error. So we apply brute force debugging methods when all else fails. Okay, so generally the brute force will add print statements or use a debugger and try everything until something works. So the only thing is it is time consuming and inefficient. Next is backtracking. So it's a common debugging approach that can be used successfully in small programs. Beginning at site where a symptom has been uncovered, the source code is traced backward until the site of the cause is found. Okay. So from a hypothesis, uh, from starting at the point where the error appears, we move backwards through the code, right? So we move backward because to trace the problem. Clear? So, but this approach is suitable for small programs. Okay. Next, third approach to debugging is cause elimination. This is manifested by induction or deduction and introduces the concept of binary partitioning. So data related to the error occurrence are organized to isolate potential causes. So a cause hypothesis is devised and the aforementioned data are used to prove or disprove the hypothesis. So once a bug has been found, it must be corrected. However, as we have already noted, the correction of a bug can introduce other errors and therefore do more harm than good. Okay, so here it is saying from a hypothesis for the bug, use deduction or binary partitioning to test it. Okay, so this cause elimination is very efficient when applied logically. Clear? So, but basically, brute force is considered to be very is a common, but the cause elimination is most professional method. Okay. So next we talk about product metrics. Okay. So software quality. So quality is defined as the conformance to explicitly stated functional and performance requirements, explicitly documented development standards, and implicit characteristics that are expected of all professionally developed softwares. Right. So, quality is nothing but how well the product will meet its requirements and follows development standards and behaves expected. Okay. So now McCall's quality factors. Factors that affect software quality can be categorized into two broad groups. First one being factors that can be directly measured, that is, defects uncovered during testing. Next is factors that can be measured only indirectly, example, usability or maintainability. Okay. So now, if you observe, directly measurable factors are like, defects found in testing. Indirect factors are like example, usability, maintainability, and all those things. So let us look this in other way, like, let's think of a software quality as does it work, or is it easy to use, or is it secure and reliable, kind of thing. Okay. So now when we talk about the McCullough's one, the operational characteristics, and it says, that about the correctness, reliability, efficiency, integrity, usability, okay, maintainability, flexibility, testability, portability, reusability, interoperability. So these are all McCall's. Okay, these are all McCall's 11 key quality factors. Okay. So again, these 11 key quality factors of McCall are divided into three main aspects of software. So under operational characteristics, we talk about this correctness, efficiency, integrity, and usability. Okay. So correctness is the extent to which the program satisfies its specification and fulfills the customer mission objectives, which means in simpler, does it meet the user needs? Okay. Reliability is the extent to which a program can be expected to perform its intended function with required precision. So first one here it is, does it meet user needs? That's it. Okay. Next, reliability, the extent to which a program can be expected, which means does it work under different conditions. Okay. Next is efficiency. So does it use the system resources well? Can be the precise of this. So that is the amount of computing resources and code required by a program to perform its function. So when it's about integrity, it is how secure it is from the unauthorized access. That's what it is saying. Extent to which access to software or data by unauthorized persons can be controlled. Next is usability. That is effort required to learn, operate, prepare input, and interpret output of a program, which means whether it is easy to learn and use. Okay. Next is ability to change. Under that, we talk about maintainability, flexibility, and testability. Okay. What is maintainability? Efforts required to locate and fix an error in the program. That is easy to fix bugs or not. Next, flexibility is effort required to modify an operational program. That is easy to modify later or not. So testability is effort required to test a program to ensure that it performs its intended function. Okay. Which means whether it's easy to test its functions or not. Then in the third category of McCall's quality, we divide that under the subsection called portability and reusability. Under that, we have portability, reusability, interoperability. Portability is effort required to transfer the program from one hardware or software system environment to other, which means can it run on different systems, right? That's what the question. Next, reusability says extent to which a program can be reused in other applications related to packaging and scope of the functions that program performs. Okay, that is, can the code be reused in other applications or not? Okay, that's what its reusability is. Interoperability is effort required to couple one system to other. So, can it work with other systems by integrating? Next, we talk about ISO 9126 quality factors. So, ISO 9126 is a global standard for software quality. So, it includes, six main quality attributes. So, let us try to understand them in detail. So, first is functionality. So, the degree to which the software satisfies stated needs as indicated by the following the sub attributes like suitability, accuracy, interoperability, compliance, and security. Okay, so whether the software meets the stated goals or not. Okay, and second one is reliability. The amount of time the software is available for use as indicated by the following sub attributes like maturity, fault tolerance, and recoverability. So reliability is always speaks how long does it stay functional without having any disturbance. That is, without crashing, let us say. Then it's usability. So the degree to which the software is easy to use as indicated by the following subcategories like understandability, learnability, and operability. So operability. That is how easily can the users understand and operate it is the another quality factor. Next one is efficiency. So the degree to which the software makes optimal use of system resources as indicated by the following sub attributes like time behavior, resource behavior. That is efficiency. Like how fast does it perform in like parameters to check our time behavior and resource behavior. Then it's maintainability. The ease with which repair may be made to the software as indicated by analyzability, changeability, stability, testability. So can it be debugged and updated easily or not is the objective here. Next, portability. So the ease with which the software can be transposed from one environment to the other as indicated by the following attributes. That is adaptability, installability, conformance, and replaceability. So the objective that which we have to understand here is, so can it be installed and run on different platforms? Okay, that's what we have to achieve this. So next, measures, metrics, and indicators we say. So a measure provides a quantitative indication of the extent, amount, dimension, capacity, or size of some attributes of a product or process. So let's try to understand the differences. An IEEE glossary defines a metric as quantitative measure of the degree to which a system, component, or process possesses a given attribute. Indicator is a metric or combination of metrics that provide insight into software process, software project, and or the product itself. Which means, so measure speaks about the basic numeric value, that is the number of lines of code, let us say. And metric speaks a quantitative evaluation of a feature. So let us say, for example, defect density equal to defects by KLOC. Okay. And in the indicator speaks like it's a kind of decision making tool which is formed from one or more metrics. Okay, for example, like overall quality trend from last 3 sprint meetings can be considered as indicator. Okay, so to summarize all these things, students, so debugging is all about tracing and fixing the root cause of errors found during the testing, and product metrics and quality models like MECALS and ISO 9126 will help us to measure how good the software is. So not just in performance but also usability, flexibility, and maintainability. Okay, so thank you, students.